So hello everyone. Now we are going to solve problems from tomorrow's contest. That is uh, contest number 1113. And due to round contest loss, so we'll be solving the first two problems. So let's start with the first problem. Now let's read the problem statement. So Alice and Bob are given a binary string S of length n. It contains at least one zero and at least one. Uh, I have I have forgotten to open the whiteboard. So it will keep open. Let's move towards reading the problem statement. So we are given a binary string that contains 0 and 1. Okay. So they each perform exactly one operation in the following order. First, Alice chooses an occurrence of 0 in S and deletes it. Okay. Then Bob chooses an occurrence of 1 in the resulting string and deletes it. Okay. Alice is the final string as large as possible. It lexicography as small as possible. So it is simple. So let's move towards it will take some time. So what is meaning of lexicographic? Lexicographic means in a dictionary order. I'll be able to explain it on whiteboard. So let's move towards the whiteboard. Now I'm erasing everything. And we were talking about what is lexicographic. Lexicography. So let's try to understand what is meant by lexicographically greater or smaller. Let's suppose the one string is 1, 2, 3, and 5, and the another one is 1, 1, 5, 5. Right. So here the second string or array, we could say, I am treating it as a string of the numbers both. So here this string like 1155 is lexicographically uh, what smaller. So if we say this is B and this one is A, so we could say that we can say that B is lexicographically smaller than A. Means like we have already seen this in like when we were in school and we used to search meaning in the dictionary. So what we use always is to do, we always search, let's suppose we need to search apple. So how we find this in a dictionary is that first we check A and then after we check B, right? And then after we check another B and we'll keep moving from left to right. And this is the same thing here that is applying here. We'll move from left to right and we'll the first value that we get that is smaller than the another string. So that would be smaller. Here if we move from here, this side from left, the first character that we encounter is one and thus so in the both strings the first character is same and when we move towards the second character in the first string, sorry, that is 2 and in the second one it is 1. So we know that 1 is less than 2. So what it means that the second string is smaller than the first one. Also, I am able to explain this thing. So we need to choose lexicographically. Uh, Alice wants to choose lexicographically smaller. Am I correct? So let's write the problem statement. What the problem saying? So Alice wants to delete uh, zeros, right? And what he want? He wants, I don't know, Alice is girl or a boy. So he's a boy. Alice and both. So what we want, what Alice wants, what we want. Alice wants final string to be as large as possible. So large. Fine. And what Bob would be doing? Bob will be deleting ones, and Bob wants the string to be as small as possible. Fine. So, and the string we are given is a binary string, means the string always contains 0 and 1s. So, let's suppose the string is 1. So, if we try to delete 0, then what would be the best possible way to delete it so that the string that we get would be a larger one, like lexicographically larger. So the best method to delete is deleting from the left side. Yes, this is left. So wait, first delete this 0, 1, 1, 0, 0, 1. And Bob will delete the rightmost, uh, oh sorry, leftmost element too, because Bob wants make the string small and he can only delete once. So to make the string small and lexicographically small, I am talking. So to make the string lexicographically small and to delete the ones, we'll be deleting from the left side. So the resulting string will be 1, 1, 1. Sorry, 1, 1, 0. Right. And there is something. Yes, they can perform exactly one operation in the following order. So yeah, this will be our final string. Fine. And let's suppose that we try to contradict this thing that we'll always delete from the leftwards. So let's delete from right. So 1, 1, 0, 0, 1. That would be the first string. And when we delete from right again, so it would be 1, 1, 0, 0. We all know that this is the like 1101 is smaller than 1110, right? Hope so I'm able to explain this to you. So what is our desired condition? We only want to delete, DL means delete first occurrence of 0 and 1, and it is. So we'll be deleting first 0 and 1, and obviously we'll get our answer. Let's try run some test cases. Or the first test is our string is 101. So after deleting first occurrence of 1, it would be 0 1, and again we'll delete 0 2 because both Alice and Bob are playing. So we'll be getting 1. So 1 is our answer in this case. And for this one, 1 1 0 0 1. So when we delete 1, it would be 1 0 0 1, and when we delete 0 2, it would be 1 0 1. Fine. We can do similar for we can also do same thing for these two. So you got this. Now we just need to implement this, and I have already submitted the solution, so I'm just going to show you the code. So, also it is visible. So here we have taken the inputs, n is the size, and I have maintained indexes 1 and 2, means the index would be storing the first occurrence of the element 0 and 1. Like when the element is 0, the 0 appear, we store index as I, and when the element is 1, like the character, then we'll store idx2 as I. And why I'm iterating from backwards? Because uh, the benefit is that we'll be storing the first occurrence. Right? We'll start from this side and we'll keep moving towards left, like leftmost element, leftmost first occurrence of 0. Right? So we have stored the index and we'll then iterate from the leftwards, left to right, and when the index won't be equal to idx1 and idx2, then we'll uh, keep adding the characters of the string into our answer string, and after that we'll print the string. Fine. So that was the code for the first one. And so this is the second problem. So let's read it first. So and this and custom integers. These arrays are distinct. You can perform the following operations on a in a number of times possible. Choose two elements A with values x and y, where x is less than or equal to y, and delete these two elements from A. Fine. Insert an integer z such that the value of A. Insert one integer z into A such that z lies somewhere between x and y. In all operations, you may arrange the elements of A in any order. Determine whether it is possible to make A equals to B. So the problem and A is an we do is the reasons we have is that we select two values x and y from array A, and when and from A we do this thing that we delete two characters x and y, sorry, two elements x and y, and instead of in place of x and y we insert z after deleting both. So this size z. So by doing these operations any number of times, our target is to make A equal to means A equals to. So this is the only thing that we need to do in this problem. So how we'll do this. First thing is that let's understand that when our answer would be no. Like if we are able to do this, then the answer is S. Otherwise, sorry, otherwise the answer is no. Fine. So how would be doing it? How we'll be doing it? So mm, the first edge case would be when value of n is smaller than a array is smaller than 2, a3, a2. So that means that no matter what we try, we would never be able to reduce a into b, because what we are uh, essentially doing is that we are deleting the two elements and we are storing one instead of two. So means we are decreasing the size one when we perform the operation one time. So means one is already less space. Ah, so sorry, my internet is on. No, it's fine. So what I was saying that if the size of the array uh, in which we are operating is already smaller than the desired array, then we would be never be able to achieve we generate a we can make a is equal to. So it would never happen. So in this case, the will print directly no, right? So this is the edge case. This is the pretty simple. Now our elements were a1, a2, a3. This array can be any size, like can be of any size. I'm just writing it for my convenience. Convenience. B1, B2. So when and we are doing one thing that we are sorting both the arrays. So yes, then the process would be easy. You will understand after some time. So when the value of a1 would be lesser than value of a1, then the sorry, lesser than or greater than. Let me think. Yeah, this. So if a1 is greater than b, means we are not able to find this bound. Right? There is no element that is present inside the array that is less than the z. Because we need to push z is after deleting x and y, but we would never be able to do that here. So for this case, the answer will be no again. Fine. Now, one thing more. Let's say the last element for which we are operating is lesser than the eth element. Like let's suppose we are iterating from 2 and a of n minus last. So what it means that the largest element that is present inside the array, in this case, is already like there is no greater element that is present in the array in which we want to operate. So for this case, the answer would be no because there is no y that we need. So here the answer would be no again. Right. Okay. Now there is one more thing. When this is multiplication, when this would happen, the answer would be again. Why? I'll explain. So the array A in which we are going to operate A1, A2, so on, A and array 2, B1, B2, so on, into this area. And this thing is smaller than this. The answer would be always two. Why? Because every time we are removing two elements and instead of this we are pushing two. So we need to reduce the size n to m, and every single time we are doing minus 1 in the size. So and every operation we need two elements. So that means to perform the operations, like the the first time when we would be able to perform the operations when n would be equal to 2 of n. Because then we would be able to delete two elements and instead of two we would be able to push one and then we would be able to reach here. Right? So for general case, like for all the cases, n should be always either equal to or greater than 2. This is the thing that we want. Fine. I don't think there is any need of running the test cases because these things I have already explained with the help of the array. Yeah, I know in terms of even 8 by 3, but yeah, it's quite understandable. So let's move towards the code of it. This, this code is done by some other method. Yeah, I have done it using storing the elements, like storing the, it's the long one, leave it. Means I in this what I have done, let me explain. That I have stored all the elements that were causing us the problem that we are not able to delete, and I have handled the handled the edge cases here. But the elements that we need to remove, I have stored inside an array, and yeah, then I have iterated and printed them. Yes, this is what I have. This is the, so it is probably this one. So here we have taken the inputs, and this is the our array A and B, and we have sorted both. And after that, when the first element of the array in which we are iterating, why AI? Because every time the array is getting decreased, and every time we are moving, we are iterating in B. So when this should be greater than the ith element in B, so we'll increase, we'll mark check as false. If ith element is greater than the last element for that particular index, then also mark check as false. And when the size of n would be less than, when the value of n means the size of A would be less than the 2n, is twice the size of B, then also mark check as false. And if check is true, then printing as otherwise. Quite simple. Yeah, that's all for this video. It's possible. So these are the two problems that I have solved till now. So I know it's the shorter one, but I needed to solve the third problem, so I'll be solving it now after this video. Obviously, with the help of the solutions and all. First, I'll try it, and after I'll go towards the tutorials of it. So yeah, that's all for this video. And yeah, I have tried something new, like recording while looking at the laptop screen. I think it will increase my ability to explain the problem. So yeah, that's all for this video. I hope you have uh, enjoyed this, what else I could say. So yeah, that's all from. Thank you so much for watching.